Hello student, welcome to my channel Kunal sir at Jee and Neet Chemistry World. So in continuations of last couple of videos, I am continuing to discussions of different types of model questions for upcoming JEE and NEET exam 2025. Now today's my first question is question number 65 as per these questions. So the number of optical isomers for this complex ion, chromium is a central metal atom and oxalate 3 times is there. So that means here if you look at that scenario is there, chromium is there and with that oxalate ion C2O4 and this is 3 times is there and overall charge is there 3 minus. It is a bidentate ligand as well as each oxalate is carrying how much charge. You can look very carefully. Oxalate ion means like these situations. C double bond O, C double bond O, O minus, O minus. Here metal ion is coming means if the charge is N plus, it's making a coordinate covalent bond like that. It's a chelating ligand. It's a bidentate ligand. So 3 times is there. Here coordination number of chromium is 6. And now they are asking how many optical isomers are possible. So now if I look at the geometry, so then how it will be like this. It is a octahedral complex. Chromium will be in central positions. And octahedral means one square plane, one above and one below. So that's why this is octahedral geometry. That means one square plane is there, one is above and one is below. So now oxalate ion, how it is forming this one? Suppose here one oxalate ion is there, they are bidentate ligand, and then here one oxalate ion bidentate, and then here one oxalate ion will be there which is bidentate positions of chromium. That's why around the chromium you look at there are 6 bonds is there. Here 1, 2, here 1, 2, 4 and here 2, 6. So now if it is taking the image, mirror image of this one, so we will get like these pictures. So we will get like these pictures. That means which is close to the mirror, this is your mirror, which is close to the mirror, that one will be close. So that's why we will get like these pictures. What pictures we will get? We will get like which is close to the mirror, that one will be the close. So here we will get like this, like these pictures, and here we will get like these pictures, and this is away from mirror, then we will get like these pictures. Now these two are non-superimposable mirror image to each other, and anyhow for this one or this one you cannot get POS and COS is not present. POS and COS means what? Is a plane of symmetry and center of symmetry, both is not present. That's why they are optically active. And now you look at, you can't make a equal half. POS means if you not able to make, there is no imaginary such plane which can divide this one or this one equal to half, either slice card or vertical. Anyway, we can't make the equal to half. That's why these don't have POS, these don't have POS, and they are non-superimposable mirror image to each other. That's why they are holding which relations? Enantiomer. Their relations is there among them, enantiomer. And now they are asking here the questions in 65, the number of optical isomers for these, how many is possible? These both are optical isomers. So that's why how many optical isomers possible? There are 2 optical isomers are possible. You look at, there is a second option is there which is nothing but a 2 optical isomers. So that's why which options will be the answer? Clearly second options will be the answer. Come to the 66 questions. In 66 questions, what they did? In 66 questions, if you look at, in 66 questions they are talking about, in 66 questions they are talking about, if you look at, there is giving one carbonyl compound. In that carbonyl compound, they are adding HCN and they are getting A. In the A, they are adding ammonia. Then they are getting B and B they are going for a hydrolysis, then they are getting C. Then they are asking which is C among these 4 options. That means it's a organic questions. Previous one was there coordination compound question. Is very important. You can expect 1 or 2 questions in NEET, JEE, even advanced compulsory questions will be there in coordinations compound. That much important this chapter it is. And this is organic questions, aldehyde ketone, another favorite and important chapter. Definitely 1 and 2 questions weightage will be there in the upcoming exam for the aldehyde and ketones. So now it's a HCN. HCN is nothing but a nucleophilic addition in ketone or aldehyde. Why? Because nucleophile is used to add in a rate determining step. If you look at the entire reactions, what is going to happen? So here we have a R, C, R, and this O double bond O is there. Now here what is happening? They are giving HCN. Now first what will happen? Acid base reaction. H plus Cn minus HCN. Oxygen lone pair will take this H plus, and then it is a forming R, C double bond and oxygen giving electron. That's why oxygen will be plus. Now this carbon will be highly electrophilic in nature. Why? Already oxygen is highly electronegative element and overall oxygen is holding the positive charge. That's why nucleophile is taking that chance to attack these carbonyl carbon which is highly electrophilic in nature, and then immediately this bond open up towards the oxygen. Then we are getting, and this is your RDS. This is your RDS. And then that's why it is a nucleophilic addition. Why? Because nucleophile adding in a RDS, rate determining step. So that's why, and here you are getting a cyanide. This is your final product. Now if you look at over here itself, now we are getting, this is called cyanohydrin compound. In this cyanohydrin compound, this is your A. In this A, they are giving here ammonia. Ammonia giving means simply you can write down the reaction. That means here H, one short mechanistic path also we can show you. H and OH, water molecule is gun, minus of water molecule. Then we are getting R, C, R, NH2, and here it will be Cn as usual. And now they are going for, this is your B. Now in this B they are going for a hydrolysis, either acid hydrolysis or basic hydrolysis. Cyanide will be converted to COOH due to complete hydrolysis. Then you will get the R, C, R, here NH2, and then cyanide is converting to COOH, which is nothing but your final product C. That is they are asking, this is your C. That is they are asking. If you look at with respect to carboxylic acid, main functional group, this carbon is a alpha carbon. With the alpha carbon attached is their NH2 group, which is nothing but a amino group. That's why it's nothing but a amino group is there, also acid group is there, and alpha positions amino group is there. That's why it is called as a alpha amino acid. You look at second option is there. That's why compound C is nothing but a which compound? Alpha amino acid. So that's why compound 66 questions, compound C is nothing but a alpha amino acid. Which option is the answer? Second options will be your answers. Is it clear? I hope everybody got the clarity. Now let us go for the next questions. In the next questions is there on the thermodynamics, 67 and 68 questions is there on lanthanides. And now this type of question is very famous. Definitely thermodynamics, another heavy weighted chapter as far as JEE, NEET or advanced concerned. Minimum 1 to 2 questions you can expect every year. So now here this is based on thermochemistry problem. So now here these two reaction is there. By applying these two reaction, how can I get this reaction? For that they are asking the delta H. That is a question. If you look at, if forward direction delta H is negative, backward direction reaction will be positive. If per mole delta H is A, if I multiply it for 2 mole, then it will be a 2A, like that idea. So now I can write down over here itself. If you look at these questions, this question first they are giving Fe2, Fe2O3 plus 3CO gas, obviously it is gives rise to 2Fe plus 3 CO2. For that delta H value, how much? For that delta H value, they are giving minus 26.8. And now next one they are giving. Next one, I have to go Fe2O3 to FeO. Now I am multiplying the second reactions with the 2 and I am taking a reverse directions. Then what I can write down? Fe 2Fe plus 2CO2 is converting to FeO to FeO plus 2CO. I multiplied 2 with the second reaction and taking in a reverse direction. Reverse direction means positive, multiplied by 2 means 16.5 into 2, because delta H is an extensive property. If mass increases, number of mole increases, it also proportionately will increase. So that's why for this delta H will be equals to, if you look at, for this delta H will be equals to 16.5 into 2, which is nothing but a 33. 33, both are kilojoule, no need to change the unit conversions. So 33 kilojoule. Now, if I add these two reactions, then I am adding these two reactions. What I will get? If I add, if you look at 2Fe, 2Fe will be cancelled out. And here if you look at very clearly, this side you have a 3CO, this side 2CO. Then 2CO will be cancelled out. 2CO cancel out. And here you will get 3CO cancel out, only 1CO will be there. And this side 3CO2, this side 2CO2. 2CO2 whole cancel out and here only will be there 1CO2. Then I am reaching the equations Fe2O3 plus Fe2O3 plus only 1CO. You look at only 1CO converting to, so 2FeO, and this side 1CO2 is there, 1CO2. That is I am reaching. And that is their desired reaction. You look at Fe2O3 plus CO gas, Fe2O3 plus 1 mole of CO gas, 2FeO plus 1 CO2. That I reach. And now simply I add these things. You also add 33 and minus 26.8, which will delta H value gives rise to 38 minus 26.8, which is nothing but a 6.2. which is gives rise to 6.2 plus 6.2, and now plus 6.2 means delta H for this reaction we reached. You look at now in the options, first option is ready. So then which options will be your answer for these questions? These questions your answer will be the first options. Is it clear to everyone? Okay. Next let us look for the lanthanide questions. Lanthanide is there, cerium 2. If you look at cerium is atomic number 57 onwards. If you look at it will go to the up to atomic number 71 lutetium. So there is a lanthanides. Now we can write down the electronic configurations of cerium. All atomic number they are provided. So how we can write down the electronic configurations for these things? If you look at for the cerium, if you look at the cerium, how can I draw these things? For cerium, if you look at cerium is atomic number 58. Like that, every one I am showing you. Cerium has a 58 electron. Before that, inert gas, xenon. So if I write down xenon code, xenon is which period element? Helium. How you have to write down? Helium, neon, argon, krypton, xenon. Helium is the first period, last element. Second period, neon, then krypton, helium, neon, argon, third period, helium, neon, argon, krypton, xenon. This is the fifth period element. Fifth period means xenon last valence shell has a 5s2, 5p6 configurations. So then after 58 means after that period. This is the last element of the fifth period. That means that cerium is a sixth period element. Obviously, it has a 6s and 6p. Obviously, it should have a 5d and 4f. Extra compared to xenon atomic number 54, compared to that there are still 4 electrons extra. An electron will fill it up lower energy to the higher energy. Energy of orbital, how we can find out? N plus L value. Previously also I told. So before the orbital what number is there? That is N value. And azimuthal quantum number L value for S orbital, it is nothing but a 0. For the P orbital, it is nothing but a 1. For the D orbital, it is nothing but a 2. For the F orbital, it is nothing but a 3. And based on that value, which will be the minimum, that orbital will go to the first. If n plus l value is coming same, then lower n value will filled up first, then only higher n value or higher n plus l value will filled up. So then as per that logic, you can calculate 4 plus 3, 7, 5 plus 2, 7, 6 plus 0, 6, 6 plus 1, 7. So obviously next filled up will be 6s2. And then here also will be there 1 electron, and then here also 1 electron. This is cerium. If 2 electron is going out, then it will go from over here. These will lost. This is outer electron. So electron filling order lower energy orbital first, then only higher energy, and removing order outer first, then only inner. That's why cerium plus 2 configurations, it will be xenon code 4F1 5D1 6S0 and 6P. As usual it was 0. Like that situation will come. That means still it will have a one unpaired electron. If unpaired electron is there, it will be a paramagnetic. Paired electron there means diamagnetic. So unpaired electron will be influenced by the external magnetic field. Diamagnetic means paired electron not influenced by the external magnetic field. That's why it is a diamagnetic. Same way, if you write down all electronic configurations, you will observe that YB2 plus this element has, if you will observe, has a pair of electron. Why? If you look at YB is giving 70. So 70 electron I have to fill it up. 70 electron means xenon code. Xenon has a 54. What are the orbital is there? 4F, 5D, 6S and 6P. So out of 54, still 16 electron is there. So that means here 2 and here 14. This is 0 and this is 0. And 2 electron will be gone, means from the 6x2, 2 electron will be there. And F14 means F will be fulfilled. There is no unpaired electron. That's why as there is no unpaired electron, then it will be a diamagnetic in nature. That's why for the 68 questions, which options will be the answer, my dear student? Answer will be the third options will be your answers. I hope it give you a lot of clarity. So now come to the next questions. In the next questions, what is there? In the next questions, another fantastic question based on chemical kinetics chapter. In chemical kinetics, what they give over here itself, it is a energy profile diagram based on one reaction. This is a reactant potential energy. This is a reactant potential energy, and this is a product potential energy level. So then this difference will be nothing but your delta H of reaction, and this to this is called as a threshold energy, potential energy of reactant, plus this to this level is called as a activation energy for the forward direction, and product potential energy level to peak of this diagram, this is called as a activation energy for the backward direction. And now if you know these things, now everything is clear. Always delta H will be equals to 2A we can write down, because this is a exothermic reaction. Why? Potential energy of the product is lower than the potential energy of the reactant. This is a potential energy level of the product, and this level is a potential energy of the reactant. So now potential energy of product minus potential energy of reactant, this is your delta H. So now potential energy of product is less value, whereas potential energy of reactant is higher value. So then delta H will come negative. That's why it is an exothermic reaction. Or another way you can explain, delta H will be equals to activation energy forward minus activation energy backward. So now you look at backward activation energy value is more. That's why in this direction this also will come negative. And now based on that questions they are asking. They are asking, if you look at XA, that means this level to this level, that level they are asking. XA they are asking. So that means XA means X to A. Then they are asking X to B. X to A, if you look at X to A level, this level to this level, this is nothing but a what? This to this level, this is the level, this is XA. So then XA is nothing but activation energy backward direction. You look at where it is there, activation energy backward direction, activation energy backward direction. Then XB, that means XB means this part, activation energy forward directions. So XB is nothing but a activation energy forward direction, that means this one. Now AB means what? potential energy product and reactant, that difference. So then AB is nothing but the enthalpy of a reaction or heat of the reactions. So enthalpy of a reaction, AB is nothing but a enthalpy of a reactions. Now X is nothing but a what if you look at? So X is nothing but the energy. This state is called as a transition state. Transition state means what? Where the old bond is not fully broken, the new bond is not fully formed. That state is called as a transition state. So that's why that X is that means this is the threshold energy level, or we can say this is a transition state. So that energy of the transition state, threshold energy means potential energy of the reactant plus activation energy forward, and also this level is peak of this was called as a transition state. So that's why X is nothing but a energy of transition state. So that's why A is matching with, if you look at S. So only two options is there, first option and fourth options. Then B is matching with a R, first option, fourth options. C is matching with a, if you look at this, C is matching with a P. So C is matching with a P, that is there only with the fourth option. And D is matching with a Q. D is matching with a Q, energy of transition state. That's why which options will be your answer? Fourth options will be your answer. I hope this give you clarity to you. Now let us look at the next questions. In these questions, if you look at next questions, what they are asking, methoxyethane and propanol are the example of isomerism of type. What is methoxymethane? Write down IUPAC name they are giving. Methoxyethane. Ethane means, if you look at ethane means what? CH3, CH2 and OCH3. This is methoxyethane. So now numbering will be there like this. 1 methoxyethane. So this is nothing but oxygen. This is called ether linkage, and both side alkyl group is there. So this is nothing but is a ether. Now here the molecular formula. Molecular formula, how many carbon? 3 carbon. How many you have a hydrogen? 3 plus 2, 5 plus 3, 8. C3H8 and oxygen. Whereas propanol, not L, it's a all means alcohol. 3 carbon alcohol. So then this is nothing but a CH3, CH2OH. Now here CH3, CH2, CH2OH. Pro means 3 carbon. So this is your formula. Now if you write down that molecular formula will be how many carbon? 3 carbon. How many hydrogen? 3 plus 2, 5 plus 2, 7 plus 1, 8. And how many oxygen? 1 oxygen. Both molecular formulas is same, and one is alcohol and one is ether. So that's why when the molecular formula is same, but their degree of unsaturation same, because by default it will be same if molecular formula is same, but reverse is not true. So that's why, but one is ether and another one is alcohol. Both are different functional group. So that's why it is nothing but a functional group isomerism. You look at third option is there, methoxyethane and propanol are the example of isomerism of type is a functional isomerism. It's not a structural, is not a position, is not a tautomerism. So they are same molecular formula, only functional group are different. That's why one is ether and one is alcohol. That's why they are functional group isomers. Is it clear? Okay. I hope I able to give you lot of clarity through the different types of question answer. To get more and more this type of video, please come into my channel, comment, subscribe, and get the clarity and be confident for your upcoming exam. Thank you very much. Thank you all.